Hello friends, now we see the theorem number 2, which is based on the sum of square of first n natural numbers of chapter, sequence and series. The theorem 2 is the sum of squares of the first n natural numbers is n in bracket n plus 1 in second bracket 2n plus 1 whole thing divided by 6 is a true for all n belongs to set of natural number. That is summation r square r takes value 1 to n is equal to 1 square plus 2 square plus 3 square up to n square, and that equal to we have to prove that n in bracket n plus 1 second bracket 2n plus 1 whole thing divided by 6, which is a true for all natural number. Now we see the proof. First of all, we consider x minus 1 whole cube formula. That can be written as x minus 1 the whole cube, that is equal to x cube minus 3x square plus 3x minus 1. So this formula can be written as x cube minus in bracket x minus 1 the whole cube, and that equal to 3x square minus 3x plus 1. Now in this formula we put x equal to 1 2 3 up to n. Putting x is equal to 1 2 3 up to n, we get, first we put x equal to 1, then we get 1 the whole cube minus second bracket 1 minus 1 0 the whole cube, that is equal to 3 in bracket 1 square minus 3 in bracket 1 and finally plus 1. Now we will put x equal to 2, so we get 2 the whole cube minus 1 the whole cube is equal to 3 in bracket 2 square bracket complete minus 3 in bracket 2 plus 1. Now we put x equal to 3, so we get 3 the whole cube minus 2 the whole cube is equal to 3 in bracket 3 square minus 3 in bracket 3 plus 1. So continuing in same manner, finally we put x equal to n, so we have n the whole cube minus n minus 1 the whole cube is equal to 3 in bracket n square bracket complete minus 3 in bracket n plus 1. Then adding respective terms of these n equations, we get n the whole cube minus 0 the whole cube is equal to 3 in bracket 1 square plus 2 square plus 3 square going on, and finally plus n square, then minus 3 in bracket 1 plus 2 plus 3 up to going on, finally plus n, and then plus in bracket 1 plus 1 plus 1 up to n times, bracket complete. So on simplifying further, we have n cube is equal to 3 in bracket, we write summation r square, r take value 1 to n, then minus 3 for bracket 1 plus 2 plus 3, we can be written as summation r takes value 1 to n, and plus 1 plus 1 plus 1 n times, for that we write n only. Therefore n cube plus 3 summation r takes value 1 to n minus n is equal to 3 into summation r square, r take value 1 to n. On simplifying further, we have n cube plus 3 into, now for summation r we write formula that proved in theorem 1, that n in bracket n plus 1 upon 2 minus n is equal to 3 into summation r square, r take value 1 to n. So now here we take a 2 as a LCM, so we have 2n cube plus 3n into n plus 1 minus 2n whole thing divided by 2 is equal to 3 into summation r square, r take value 1 to n. So now we take n common from numerator, so we have n in bracket 2n square plus 3n plus 3 minus 2 whole thing divided by 2. Now the term 3 which is on right hand side, we have to shift on LHS, so we get in the denominator 2 into 3, so that equal to summation r square, r take value 1 to n. On further simplifying, we have n in bracket 2n square plus 3n, and then 3 minus 2 we get plus 1, totally divided by 6, which is equal to summation r square, r take value 1 to n. Now the terms in the numerator, that 2n square plus 3n plus 1, this is a quadratic equation, and that we have to factorize. So consider the term 2n square plus 3n plus 1, that equal to, now the first term is a 2, last term is a 1, so their multiplication is 2 multiplied by 1, we get 2. Now 2 can be factorized as 2 ones are 2. So this term can be written at 2n square plus 2n plus n plus 1. Now we make it a group of 2 terms. So the next step will be 2n in bracket n plus 1 plus 1 in bracket n plus 1, and from that we take n plus 1 common, so we have n plus 1, and in second bracket we have 2 n plus 1. So in this way, 2n square plus 3n plus 1 can be factorized as n plus 1 and 2n plus 1. So the next step will be n into n plus 1 into 2n plus 1 totally divided by 6 is equal to summation r square. I take value 1 to n. So therefore, finally, summation r square, I take value 1 to n is equal to n in bracket n plus 1 second bracket 2n plus 1 upon 6. So this result is a true for all set of natural number. So in this way, we prove the sum of square of first n natural number is n in bracket 2n plus 1 in second bracket 2n plus 1 and whole thing divided by 6. So this is a required proof for the given theorem. Thank you.